Welcome. The first chapter we are discussing in the biochemistry is classification of amino acid, and it's a very important chapter. You take any exam, be it FMG, be it NEET-PG, INI-CET, they love to ask the question on classification of amino acid. So first, let's understand what is amino acid is. See, we know that carbon is having 4 valencies, and if out of these 4 valency, one of the valency is having the amino group, and the another valency is having the acidic group. If amino group and acidic group are there, then this is called as amino acid. NH2 is the amino group, COH is the acidic group. The rest of the 2 valency, one will be a hydrogen, and fourth valency can be anything. It can be hydrogen, it can be carbon, it can be alcohol, sulfur, anything. So I'm writing R. This R stands for any group. So this is one of the simple structure of amino acid that we can say. Means in an amino acid, there will be one amino group, one acidic group. That is a bare minimum requirement. So we can say that amino acid is a monoamino and monocarboxylic acid molecule, right? There is mono means one amino group and one acidic group. Now, to go into more detail, first let's understand 2 more definition. One is called as alpha amino acid. What is alpha amino acid? To understand alpha amino acid, we need to understand what is alpha carbon means. See, in the 11th class, you must have learned about how to do the carbon numberings. How do we do the carbon numberings? For example, in this particular carbon chain, if I tell you that, okay, let's do the carbon numbering. We start the carbon numbering from the functional group, and in this, the functional group is COH. So you will start from here. This is carbon number 1, carbon number 2, 3, and likewise. This is one of the way of doing carbon numbering. But there is one more way by which we can do the carbon numbering. What is that? This is the functional group. The carbon which is next to the functional group, this is called as alpha carbon. Then we have the beta carbon, gamma carbon, delta, epsilon, likewise. Right? So what is the meaning of alpha? Alpha carbon means the carbon which is next to the functional group is called as alpha carbon. So we have understood here, this is the alpha carbon, the carbon next to the functional group. If we apply the same concept on the amino acid molecule, see, this is the structure of amino acid. Here is the functional group. The carbon which is next to the functional group is referred as what? Alpha carbon. And you can see that in the amino acid, the amino group is attached to the alpha carbon. So because in the amino acid, amino group is attached to the alpha carbon, such amino acid are called as alpha amino acid. If the amino group is attached to the beta carbon, then it is called as beta amino acid. And in humans, most of the amino acid are found in the alpha form. What is the meaning of alpha form? Amino group attached to the alpha carbon. So most of the amino acid are found in the alpha form. Alpha form. There are only few exceptions, and they love to ask this question. What is not an alpha amino acid? The examples are beta alanine. As the name is suggesting, it's a beta amino acid, beta alanine, beta amino isobutyrate. So these are the beta amino acid. And when they will ask this question, obviously they will not give you the, they will ask like this. All of the following are alpha amino acid except, and one of the option will be alanine. They will not write beta alanine, right? Because that is going to be very much evident. Then the second concept is to be understood is what is D and L amino acid, right? What is the meaning of D and L? See, that is showing you where is the amino group. If the amino group is on the left side of the amino acid, if the amino group is on the left side, or the amino group is on the right side, on the right side. If the amino group is on the left side, that is called as L amino acid, and if it is on the right side, that is called as D amino acid. And in humans, the amino acid are found in the L form, right? So L amino acid, they are found in humans, and D amino acid, they are found in bacteria. That is why in the pharmacology, they make a question that when we make an antibiotic, and that antibiotic is designed to destroy the protein or the translation in the bacteria, they are designed in such a way they are going to take the D amino acid. So that is why when you take the antibiotics, that is not going to harm you, that is going to stop the proteins, the translation in the bacteria, because they are designed towards the D amino acid. D amino acid. So antibiotics are designed against which amino acid? D amino acid. Right? Next concept. Before going into the classification, I told you that we need to understand some concept. The next we need to understand is what is amino acid. See, normally the amino group, see, this was the structure of amino acid. If you remember, the carbon is having 4 valency, one of the valency is having the amino group, another is the acidic. So that is called as amino acid. But normally this amino group is free. But if you look at this particular structure, look at this structure and look at the amino group. I am highlighting with the yellow color. Here is the amino group. This amino group is bound in a ring structure. If the amino group is bound in a ring structure, this is not called as amino acid. This is referred as amino acid. So amino acid means amino group is not free, instead bound in a ring structure. If the amino group is bound in a ring structure, that is called as amino acid. Amino acid. And what is the name of this ring? The name of this ring, this is the pyrrolidine ring. If they want to ask you a difficult question, they will ask you what is the name of this ring? Pyrrolidine ring. And what is the name of this molecule? The name of this molecule is proline. So if the amino group is not free, it is bound in a ring structure, then such amino acid is called as amino acid. And what is the example of amino acid? It's a very important question. The example of amino acid, proline. Very good. The last concept before going into the classification, the definition of chiral carbon. The meaning of the chiral carbon is, we know carbon is having 4 valencies. If all the 4 valencies are having the different groups, say for example, here it is X, Y, Z, A. All the 4 are different. If all the 4 are different, such carbons are referred as chiral carbon. And in the chemistry class, you must have seen and discussed about this diagram. If you remember, the mirror image, right? Or the optic isomer. Whenever we want to make a mirror image of any molecule, it is only possible if the molecule contains a chiral carbon, right? So chiral carbon is required to make the mirror image. It's required to make the mirror image. If the chiral carbon is not there, we can't make a mirror image, or we can't make the optic isomer. And this particular phenomena is related with one amino acid. Look at this amino acid. Look at this structure. This is the structure of glycine. The structure is not important. That is just to make you understand the things. This is the structure of glycine, and what you can see is, here is the amino group, here is the acidic group, the third valency is hydrogen, and in the glycine, the fourth valency is also hydrogen. So first tell me, is it a chiral carbon? All the 4 valencies are different? No, right? Because this and this valency is same, so it's not a chiral carbon. So I can say glycine does not have chiral carbon, and because glycine does not have chiral carbon, it cannot make optic isomer, it cannot make mirror image, it is optically inactive. So they ask this question, which amino acid is optically inactive? Glycine. The structure of glycine, there is no chiral carbon, hence optically inactive. Optically inactive. So we have understood 3 definitions. Let's recall them first. Most of the amino acids are found in which form in humans? Alpha or beta? Alpha, right? Second, we have discussed that if the amino group is not free and it is bound in a ring structure, that is called as what? That is called as amino acid. And what is the example? Proline. Then we have discussed which amino acid is optically inactive? Glycine. These are the 3 important questions. Now coming to classification of amino acid. But can you tell me that, okay, how many amino acids we have in the humans? We have 22 amino acids. Earlier there was 20 amino acids, now we have 22 amino acids. So, before I start the classification, let's understand one basic concept. For example, right now, let's say there are 22 students are there in the classroom, and I tell them that, okay, I want to classify you. The first question that will come to your mind is that on what ground, on what basis you want to classify. Then I will say that, okay, I can classify on the basis of your native state, right? Some of you are from Rajasthan, some are from Delhi, some are from Kerala, and likewise we can classify. Or I can classify on the basis of your year of birth, or I can classify on the basis of your net worth, right? So we can do the classification on various bases. So when we talk about the classification of amino acid, we need to understand that on what ground we are doing this classification. So the first classification we are going to discuss, that is based on the R group. Classification of amino acid based on the R group. And what was the R group? Remember, this is the R group. R means it can be anything. In the structure of amino acid, we have the amino group, we have the acidic group, the third valency is hydrogen, and fourth can be anything. It can be sulfur, it can be alcohol, it can be hydrogen, it can be carbon chain, it can be a branch carbon chain, it can be anything. So, on the basis of this, we are doing this classification, right? So, the first subcategory is simple amino acid. The meaning of simple amino acid means that there are some amino acid out of 22 where the R group is either replaced by a hydrogen or by a simple carbon, right? If you look at this structure, look at here. This is the R group. These structures are just for your reference. Here is the R group. Instead of R group, there are some amino acid where we have the hydrogen and maybe a simple carbon, right? These are called as simple amino acid. And the examples of the simple amino acid, it is glycine and alanine. Glycine and alanine. This is the structure of glycine. Although that is these, no one is going to ask you these structures. That is just for the understanding purpose. And this is the structure of alanine, glycine and alanine. See, whatever exam you are preparing for, maybe for INI-CET, maybe for NEET-PG or the FMGE exam, you know that one of the most haunting subject in the entire medical sciences, one of them is the biochemistry. And my personal experience is, it's not that I am teaching biochem, so I will be always saying very good about biochem. It's not like this. But you know that if you will be very attentive in this classroom and you were listening to these lectures very nicely, I will make sure that you will remember the most of the things in the classroom itself. It's not going to be a very lengthy biochemistry. It's going to be very crisp, to the point, but you have to be with me, and that will give you the extra edge in the exam. Because most of the students are lacking, one of them, the subject they are lacking is the biochemistry. And this is one of the most scoring subject. So how, and there are so many diseases we are going to discuss. Yeah, we are going to relate this with the pharmacology, with the medicine, with the dermatology, as and when possible. So the simple amino acid, you know that one of the simple thing to be done in any people gathering or any party, one of the simple thing that we do is the singing, right? Singing in the Hindi is Gana. So I can say Gana is a simple thing to do. Gana or Ga is a simple thing to do. Simple amino acid is Ga, right? Gana is a simple thing to do. The mnemonic is Ga, glycine and alanine. Glycine and alanine. And out of these two amino acid, the most simplest is glycine. This is the simplest amino acid. Simplest. And alanine is the most common amino acid found in our body. Most common amino acid we have in our body, it's alanine. Coming to the second category, the branch chain amino acid. Branch chain amino acid. See, irrespective of your medical school, whether it is in India or maybe outside India, you have seen that in every batch, there is one student who have a very huge relationship. He knows every batchmate. He knows every junior, every senior, the professors, and everyone knows him also. He has a huge relationship. He has a branch relationship. And what we call him? We call him the Neta. He is the, ye hamare batch ka Neta hai. He is the Neta of our batch. He is the leader. How is, you and me, we are not having that huge branch relationship, but he is able to have, because he has a very peculiar character. He is very live-hearted, right? To have a branch relationship, the person has to be live-hearted. The mnemonic for branch chain amino acid, live. To have a branch relationship, the person has to be live. The live stands for leucine, isoleucine, and valine. Leucine, isoleucine, and valine, live. And what is the meaning of this branch chain amino acid? That the R group is replaced by a branch carbon chain. R group is replaced by a branch carbon chain. Here you can see, this is a branch carbon chain instead of R group. Here also you can see. Here also you can see. So this is the leucine, isoleucine, and valine. The structures are not important. That is just for pure for the understanding purpose. No one is going to ask you the MCQ on the basis of these structures, right? Let's move to the next category. Yes, your favorite one. The alcohol containing amino acid means the hydroxyl group or the alcohol containing amino acid, right? The OH group, alcohol containing. The examples of alcohol containing, can you tell me what are the examples of alcohol containing amino acid we have? Yes, it is serine, threonine, and threonine, alcohol containing amino acid. You know what? If you have done your MBBS in the North Asian countries, maybe Russia, maybe Kazakhstan, Kyrgyzstan, China, somewhere there is a tradition in these countries, including China also, that whenever a guest comes to their home, they offer alcohol to them. Unfortunately, we don't do that in India, right? When a guest comes to us in India at home, we don't offer alcohol, daru pilo, right? We don't do that. So unfortunately, it's not like this in India. But you guys have been there for so many years, so you may be knowing if you were there. So what happened was, it was around 2016 and somewhere 16, 17. I was having a class in the city of Nanjing, that is there in China. It is around 3 hour distance from Shanghai. So someone has organized a class there, and that was basically the students only. They have organized the class. They have contacted us, and they told that we want the biochemistry session. So I said, okay, fine. I will travel from my institute. So I landed at Shanghai airport around 5 p.m. and it was around 3 hours drive to Nanjing. So around 2-3 students came to take me at the receive at Shanghai airport. We started driving, and we were talking very casually, right? And all being from North India, we were talking in Hindi. So we were talking, and after 1 hour or so, there was one student. He said, "Sir, from tomorrow onwards, we are going to have a very hectic schedule, right? For the first time, we are going to have the class from 9 to 7, 9 to 7, back-to-back classes, and it's going to be very hectic. And on the last day, you have to catch the flight also after the class. So we will not get the time afterwards. So let's have a party today. Let's have a party today." I understood their meaning directly, and I bluntly said, "I don't drink." And there was a very awkward silence for a couple of minutes in the car, and then just to make the environment light, I started talking again, and likewise, and again the things started normalized. Then when we reached Nanjing around 8 p.m., they were dropping me at hotel, and we were now everything was completely normal again. And again, the same student has gathered the courage to say that, "Sir, we understood that you don't drink. What you do is, sir, you just come and sit, because we just need a reason to start. Baki to hum dekh lenge. You just come and sit." I said, okay, fine, I will come and join you guys. So we decided that 9 p.m. okay, they are going to start. So everyone was on time. Class to time pe no one comes, but in the party everyone comes on time or before time. They started drinking, right? And I was also sitting there. They have given me a glass of juice, and I was drinking the glass of juice. Say, for example, I was here. Now, after around 1.5 hours, one of the students said to me, and now they are little drunk. So one of the students said to me, "Sir, you are coming here for the Nanjing in the first time, and maybe you will never come again, or maybe we never meet again, right? No one knows you here. So you also try once. It's going to be good." So I thought, okay, fine, let's give it one pack to me. So I took one. I drank one, and yes, like others, I also liked it. And now the party was having a different color altogether. Then I asked on my own. I asked for the second one. Then I asked for the third one. And as soon as I asked for the fourth one, the student who was organizing the class, he has collected the money, and he was the one who was supposed to coordinate this class. He was thinking that this guy is drinking for the first time. He was thinking that I am drinking for the first time, and I don't know that what is going to happen next day morning. I will not be able to take class. I will have hangover, nausea, vomiting. I will not be able to take the class. And who will be responsible for this? This guy. So he has to stop me, right? And since being all from North India, we were talking in Hindi. So he said to me, "Sir, please stop. This is alcohol." What he said to me is in Hindi, because we were talking Hindi. So he said, "Sir," he said to me is something like this: "Sir, thero, sir, thero, this is alcohol. Sir, thero, this is alcohol." So alcohol containing amino acid, sir, thero, this is alcohol. Nothing such incident happened. Nothing happened like this. This, right? So the alcohol containing amino acid, sir, thero. But interestingly, there is one more amino acid which also have the hydroxyl group. But we are deliberately going to write that in a separate line. The name of that amino acid is tyrosine. Let's write down. Tyrosine also contains hydroxyl group. But we are deliberately writing in a second different line. But we will come back and we'll complete this statement. You will understand that why we are writing it in a separate line. So alcohol containing amino acid, sir-thero, and there is one more, tyrosine. But tyrosine is little different, so we will come back and we'll complete this statement. The next is sulfur containing amino acid. So instead of R group, there are some amino acid where we have the sulfur group. And you know the example, yes, it is methionine and cysteine. Methionine and cysteine. How we can remember? We can remember like this. What is there inside the meaty cyst? Meaty cyst. What is inside the meaty cyst? Sulfur. Sulfur. This is how we can remember meaty cyst. Okay. The next is the aromatic amino acid. There are some amino acid which have a very peculiar smell. Very peculiar smell. Right? Okay, let's do an experiment and then we'll come back to this. Let's assume that we are sitting in a closed environment, in a closed airtight chamber, and we do an experiment there. We bring a tire there and we burn the tire. After some time, there will be smoke of that tire. Everywhere there will be smell of that tire. And if we want to get rid of the smell, what we have to do? We have to turn on the exhaust fan, so the air will go out, right? So what I'm trying to make you understand is, whenever there is a smell, if you want to get rid of the smell, you have to turn on the fans. You have to turn on the fan. So the amino acid which have fan in the name, whichever amino acid is having fan in the name, they will have smell also. This is the way to remember. Can you tell me any amino acid which is containing fan in the name? Is something is coming in your mind? Yes, rightly. It is tryptophan. Fan in the name, it's aromatic. Tryptophan. Can you tell me one more, where the fan in the name, in which amino acid? Yes, phenylalanine. Fan in the name. Okay, what was the smell in the experiment? What was the smell? What we have burned? The tire. So, tyrosine. Tyrosine. Tryptophan, phenylalanine, tyrosine. There is one more. Histidine. So how we are going to remember histamine? Because the first three are easy to remember. Tryptophan, phenylalanine, tyrosine, there is no problem. But how to remember histamine? Yes, how we are going to remember? As everything is not going to be a story. You have to put some hard work to remember also. So मेहनत करेंगे. How we are going to remember? मेहनत करके याद रखना पड़ेगा. You have to do some hard work to remember this. Hard work. Now, the aromatic amino acid have a special character also. There is one more special character, that if you put the aromatic amino acid in the sunlight, they are going to absorb the UV rays. The other amino acid cannot do that. The aromatic amino acid can do that. The UV rays, the frequency is somewhere between 256 nanometer to 290 nanometer. So if you put the aromatic amino acid in the sunlight, they are going to absorb the UV rays. All the aromatic amino acid can absorb the UV rays, but they ask this question, very important question. They ask this question, which amino acid has the maximum UV absorption out of all the four? Which has the maximum UV absorption? The maximum UV absorption it is seen with tryptophan. Sometimes instead of the word UV rays, they can give the frequency of the light. They can say that We have put the amino acid in a particular light where the frequency was, let's say, 270 nanometer. 270 nanometer means UV rays, right? 256 to 290 somewhere, this is UV rays, and they will say that who will have the maximum absorption of this light? It is tryptophan. The next is the acidic amino acid. Okay, before I go to acidic amino acid, can you tell me one simple answer which I have already told you actually? In a normal amino acid, how many amino group and how many acidic group? How many amino group, how many acidic group? One amino and one acidic, right? Mono amino, mono acidic. Acidic amino acid will be such an amino acid where there is more and more acid. So that will be also called as monoamino dicarboxylic acid. Monoamino means amino group is just one, but how much is the acid? It's more than one. More than one. That is called as acidic amino acid. Acidic amino acid. And if I ask you how we write acid, we write the acid like this, COH, or we can write like this, COO negative. Either you write COH or you write CO negative. So if I ask you that, what will be the charge on the acidic amino acid? What will the charge on the acidic amino acid? What is the charge on the acid? Negative. And because in the acidic amino acid there is more and more acid, so what is going to be the charge? Negative charge. So acidic amino acid are the negatively charged amino acid. So they can frame the MCQ like this also. Negatively charged amino acid. Okay. Let's answer one question. Nothing to do with amino acid, just a simple question. You must have heard about a molecule called as lactic acid, right? Can you tell me what is the difference between lactic acid and lactate? What is the difference? Yes, there is no as such gross differences there. Lactic acid or lactate, more or less, they are same. Means I can say like this: the other name of lactic acid is lactate. In the same way, we have two amino acid which are acidic: glutamic acid and aspartic acid. What will be the other name? Glutamate and aspartate. So if they want to ask you that which is a negatively charged amino acid or which is an acidic amino acid, they will give you the option aspartate and glutamate. Aspartate and glutamate. So the acidic amino acids are aspartate and glutamate. Okay. The next, amide group containing amino acid. Now, what is this amide group containing amino acid? When I said sulfur containing, we understood sulfur is H. When I said alcohol containing, you understood alcohol means OH, right? But if I say amide group containing amino acid, to find out the amide group containing amino acid, we have to find what is the meaning of amide, right? That what we are searching for. Amide means CONH2. CONH2. CONH2 is called as amide. CONH2 is called as amide. So we are searching for this amide group. And you know a very interesting character about amide, that amide, this amide group loves acid. Wherever the acid, it will go and it will attach on that. And we know that there are two amino acids which have excess amount of acid. What are the names of these two amino acids? Aspartate and glutamate. This amide loves the acid. It will go and it will attach on the acidic amino acids such as aspartate and glutamate. If this amide group goes and attaches on the aspartate, the molecule that is going to be formed, it is aspargine. So aspargine is a amide group containing amino acid. In the same way, this amide can go and can attach on the glutamate. The molecule that we are going to make, it is the glutamine. So amide group containing amino acid, aspargine and glutamine. Aspargine and glutamine, right? Okay. The next is the basic amino acid. Basic amino acid. So normally the amino acid is monoamino, monoacidic. But if I say basic amino acid, means there is more amino group, right? So it will be also called as diamino monoacidic. Diamino means amino group is more, amino is the basic group, right? And acid is acid. So monoacidic but diamino. These are called as the basic amino acid. What was the charge on the acidic amino acid? What was the charge on the acidic amino acid? Negative. So the opposite will be on the basic. Basic will be the positively charged amino acid. These are the positively charged amino acid. What are these the positively charged or the basic amino acid? It is histidine, lysine, and arginine. How we can remember this? We'll remember like this. If you have ever been to a oncology ICU, in the oncology ICU, there are some patients who are terminally sick, right? We don't have any treatment, metastasis is there, extensive metastasis, and we and the patient, even the relatives, also everyone knows that the patient is going to die soon, right? And we don't have anything to be done. So if you ask someone that, what is your last wish? What is your last urge? If you ask someone a last urge, it's going to be very simple. It's going to be very basic, right? So they will say that I want to visit a particular holy place, or maybe I want to meet someone, something like this, right? So we will remember like this. Why we are talking about this is because his last urge is very basic. His last urge is very basic. So basic amino acid, histidine, lysine, arginine. His last urge, very basic, very basic. And among these three, which is most basic it is arginine. Arginine. Right? So this is the first classification that we are discussing about the amino acid, right? That is based on the R group. The R group can be sulfur, can be alcohol, can be amide group, can be acidic group. Based on that, we have made this classification. There is one special category. There is one special category that is called as the heterocyclic amino acid. Now, what is the meaning of heterocyclic amino acid? See, if a amino acid is containing a ring of carbons and one of the molecule is other than carbon. For example, if I just draw a structure for you, let's say here is the acidic group, here is the amino group, here is the hydrogen, here is the R. Now what I'm saying is that in this amino acid, instead of this R, there is some carbon chain or carbon ring. And in this carbon ring, here is the carbon, here is the carbon. There is one molecule which is not carbon, something else, and then again the carbon. If such a structure is there, where amino acid is containing a ring, and the ring is mainly made up of carbon, but there is one molecule which is not carbon. If such cyclic amino acid is there, this is called as heterocyclic amino acid. Why it is called as hetero? Because all are not carbon, right? One molecule is other than the carbon, right? So that is called as the heterocyclic amino acid. Heterocyclic amino acid that is containing a carbon ring, and in that ring, one atom is not carbon. And the examples are tryptophan and histidine. So tryptophan and histidine, they are also called as heterocyclic amino acid. That is an extra point. If you can remember it, it's very good. Otherwise, just remember these 8 categories which we have discussed. This is the 9th one that if you especially want to remember what is heterocyclic, this is the point to be remembered, right? Okay. Let's move to the second classification of amino acid. And it's a very simple classification. It is based on the water solubility. I told you that whenever we want to do classification, we need to understand that on what basis we are doing the classification, on what ground we are doing the classification. So the second classification we are discussing, it is based on the water solubility or the polarity. The amino acids are water. There are some amino acids which are water soluble, and there are some which are water insoluble. The water solubles will be also called as hydrophilic or the polar amino acids, hydrophilic or polar. And water insoluble will be referred as hydrophobic or the non-polar. So based on the water solubility, we can have this classification. Now, there is a problem that we have total 22 amino acid. Some of them will come in the water soluble, some of them will be water insoluble. It is going to be difficult to remember this entire classification directly. Although if you just remember one category, let's say you want to remember water soluble ones, if you just remember the water soluble ones, the remaining are the water insoluble, then also it is going to be difficult because the list will be long, right? We might miss 1 or 2 names. So how to overcome this problem? It's very simple. We are not going to remember the examples. We are going to remember the categories. Now, what does that mean? That means, see, When we were in the 11th, 12th class, you used to go to the chemistry lab. If you recall those dates, there were small bottles were there, right? H2SO4, HNO3 were there. What we used to do was we used to take few drops of the acid, we used to dilute them in the water, or maybe the base, we used to dilute them in the water. So acid and base, they were water soluble. So what we can say is, wherever we have the excess amount of acid, excess amount of base, they are going to be a water soluble molecule, right? So I can say, yes, we have the acidic amino acids, we have the basic amino acids, and they are going to be water soluble, right? So what are the acidic amino acid? So the acidic amino acids, they are going to be water soluble. Can you tell me the examples of acidic amino acid? Yes, the aspartate, glutamate, they are going to be water soluble. And what is the charge on acidic amino acid? Positive or negative charge? Yes, they are negatively charged. Negatively charged. In the same way, we have the basic amino acid. They are also going to be water soluble. They are positively charged. And I have told you the mnemonic also. What was the mnemonic? His last urge is very basic. Histidine, lysine, and arginine. They are basic amino acid. Okay. So they are going to be water soluble. Wherever there is acid or base, they are going to be water soluble. Okay. Can you tell me, there is one molecule, if you're listening very carefully, you can answer. There is one molecule which loves acid. There is one molecule which loves acid and goes and attaches on the acid. What is the name of that? Amide. So can I say like this? Wherever is the amide group, there is acid. And acid is water soluble. So I can say amide group containing amino acid will be water soluble. Amide group containing amino acid. And the example was, can you tell me the example looking at these examples? Yes, what are the amide group containing amino acid? Asparagine and glutamine. Okay. Answer me one more question. What do you think? Vodka is water soluble or not? Vodka, whiskey, alcohol. Yes, there is no doubt. There is no doubt, right? We are doing every day the same. Alcohol is water soluble. So I can say if alcohol is water soluble, alcohol containing amino acid will also be water soluble. So alcohol containing amino acid, we have the. Do you remember the alcohol containing amino acid? What are the alcohol containing amino acid? The story I told you, Sir Thero, right? So the alcohol containing amino acid, they are going to be water soluble. The example is Sir, that is serine and threonine. Okay, but there is a twist. If you remember, when I told you the alcohol containing amino acid, there was Sir Thero, but there was one more amino acid. What was the name of that? Tyrosine. The reason we have written tyrosine in the separate line at that time, because tyrosine contains alcohol group, but it is not very water soluble. It's not very water soluble. So let's go back to that fourth subcategory and complete that statement. Third subcategory, that tyrosine also contain hydroxyl group, but it is water insoluble. It is not water soluble. It is mostly water insoluble. Water insoluble. Right? That is why we have written the tyrosine in the separate line. It is not water soluble, it is water insoluble. Okay. So now you answer me one question without looking at here. Let's answer me one question. Can you tell me four categories which are water soluble? Four categories water soluble. Acid, base, amide, alcohol. Right? It's so easy to remember. These four categories amino acid are water soluble or they are polar amino acid. But if I change the question, which of the following amino acid is polar and charged? Polar bhi hai and charged bhi hai. Polar and charged. Polar means water soluble and charged means either negative or positive. Then the answer will be this category or this category. Polar plus charge. So polar can be charged or polar non-charged, right? That can also be there. Apart from that, there are two more amino acids. Their entire category is not water soluble, but they themselves they are water soluble, and that is glycine and cysteine. They are also water soluble. Their entire category is not water soluble. So there are four categories which are water soluble: acid, you have to remember, acid, base, amide, alcohol, and apart from that, glycine and cysteine. Glycine and cysteine. These are the amino acids which are water soluble. The remaining all the amino acid, remaining all are water insoluble. And the among the remaining ones, the most water insoluble, most hydrophobic, it is isoleucine. Leucine, isoleucine, they are very hydrophobic, very hydrophobic. They are water insoluble. Right. So if we take the 22 amino acids and we arrange them in a sequence on the basis of their water solubility ki basis pe, if we arrange them, it is going to be like this. The most water soluble, it is arginine, the maximum water solubility, and the least water solubility is leucine or the isoleucine, that is having the least water solubility. The maximum is arginine. And the remaining are in between. Say, for example, somewhere here it is aspartate, glutamate, threonine. That is going to be there. And there is one amino acid which is somewhere in the gray area, and that was tyrosine. Although we consider tyrosine mostly as a water insoluble one, but it is somewhere in the gray area. Somewhere in the gray area. Why I am saying so? Because if they ask the question, all of the following are water soluble except, what will the best answer? You have to answer on the basis of this spectrum. I will show you some questions so that you will understand, you will get an idea. See here. There are two questions. Identify the water insoluble one. Which of the following is water insoluble? If I write down the categories, that will make the life easier. Serine, it is alcohol containing amino acid. Threonine, alcohol containing amino acid. Isoleucine, we know that isoleucine is the most water insoluble. And tyrosine also contains alcohol, but it is also water insoluble. But if you have to select the best answer, which is water insoluble, what you are going to select, tyrosine or isoleucine? Yes, you are definitely going to select the isoleucine, right? Because that is the most water insoluble one. So here you will consider tyrosine as a water soluble one, because the other water insoluble, more water insoluble was there in the choice. But if you look at the next question, the same question, which of the following is water insoluble? Serine, alcohol containing. This is alcohol containing. This is acid. They all are water soluble. Tyrosine also contains hydroxyl group. But will you consider this water soluble or not? Now we are not going to consider this tyrosine. So tyrosine is somewhere in the gray area. We can say whether to say it is water soluble or not. We will see on the other options. Based on the other option, we will try to select it. So that is one of the kind of MCQ that can be framed from this spectrum, right? So that has to be accordingly. You have to keep that thing in the mind, and based on that, you will answer such MCQs. The next classification that we are going to discuss, it is based on the metabolism. If you take the 22 amino acids and you do the metabolism, after the metabolism, there are some amino acids. After the metabolism, they are going to generate the ketone body. What is ketone body? We will discuss in the subsequent videos. But as of now, if you take the amino acid, there are some amino acid when you do the metabolism. After the metabolism, they are going to make the ketone bodies. If they make the ketone body, they are called as ketogenic amino acid. Ketogenic amino acid. There are some amino acid, after metabolism, they are going to generate glucose. From amino acid, we can make glucose. From the amino acid, if you are making glucose, such amino acid are called as glucogenic amino acid. So we have the ketogenic amino acid, we have the glucogenic amino acid. And there are some amino acid which can make the ketone body or can make the glucose depending on the requirement of the body. So we can say there are some amino acid which can generate ketone body as well as can generate glucose, both. So we'll say that they are keto plus glucogenic. Keto plus glucogenic, right? When it comes to the ketogenic, the most ketogenic, it is leucine. Most ketogenic. You can remember like this, the most common name of a pet cat. What is the most common name of a pet cat? Lucy. Leuci. Leuci is the most common name of a pet cat. There is one more amino acid which mostly makes the ketone body, that is lysine. Lysine is also ketogenic, but if you have to select one, which is the most ketogenic, who makes the maximum ketone bodies, leucine. When it comes to the keto plus glucogenic, before I write the examples of the amino acids, can you answer me that which amino acid are aromatic? Remember the story, wherever is the smell, what will come there? Fan. So what are the aromatic amino acid we have? Yes, can you tell me the names? Tryptophan, phenylalanine, and what was the smell? Tyrosine. So what is keto plus glucogenic is actually, it is exactly same as aromatic. So keto plus glucogenic, it is tryptophan, phenylalanine, tyrosine. Can you tell me what was the fourth one there? What was the fourth one there in the aromatic category? You have to remember with the hard work, mehnat. Yes. What was that? Histidine. There it was histidine. Here it is isoleucine. That is just one change that is there. So this is just a way to remember. If you want to use that, it's okay. If not, you can remember it directly that these are the four which are keto plus glucogenic. And the amino acid which is going to make the glucose, it is alanine. Alanine is the most glucogenic amino acid. Most glucogenic. There are many amino acids which can make the glucose. Actually, the remaining all the amino acid out of the 22, there are 2 which are ketogenic, there are 4 which are keto plus glucogenic, remaining all are glucogenic, and among them, the most glucogenic, it is alanine. So, the most ketogenic, leucine. Leuci is the most common name of a pet cat, Leuci. And the most glucogenic, it is alanine. So this is the third classification of the amino acid. The first classification we have discussed on the basis of the R group. The second classification we have discussed on the basis of the water solubility, water soluble, water insoluble. The third classification we have discussed on the basis of the metabolism. The fourth classification, the fourth and the last classification, is the basis on the nutritional requirement. And you must have discussed that multiple times in the schools also. On the basis of nutritional requirement, there are some amino acid out of 22 which is very essential to be taken in the diet. Our body cannot synthesize them. You have to take them in the diet. These are called as essential amino acid. There are some amino acid which can be synthesized in your body. Whether you eat them or you don't eat them, your body will make them. So these are called as non-essential amino acid. They are so important that your body is by itself is going to make it, right? Whether you eat it or not eat it. And there are some amino acid which is required. They must be taken in the diet when we were in the growing age. And these are called as semi-essential. In some particular states, they are going to be taken in the diet. That is semi-essential amino acid. So out of 22 amino acid, there are some which are essential. There are some which are non-essential. And there are one that is going to be the semi-essential. The definition is not important. The examples are important. So there is some controversies there. But I will tell you the answer according to the netboard, what is there in their question bank. Based on that, I am telling you this fact. There is some controversy. If you see the Satyanarayan or you see the Harper Lippincott, the answers are going to be different. So when it comes to the essential amino acid, there are total 9 essential amino acid we have. In Satyanarayan, it is written 8, but in the Harper Lippincott, it's written 9. So we'll go with that. That is TV till 9 p.m. H. TV till 9 p.m. H. These are the 9 essential amino acid. TV till 9 p.m. TV till 9 p.m. What is the meaning of TV till 9 p.m. H is, see, if I say, okay, isoleucine, whether it is not there, if I say isoleucine is essential or not, I is there, isoleucine, I is there, so it is essential. I is there, so it is essential. When it comes to leucine, if someone asks leucine is essential or not, L is there, leucine, L is there, so it is essential. If valine is essential or not, valine, V is there, so it is essential. So what we can say is, what we can do is, if they ask the question, which of the following is essential or not, you will just use this mnemonic TV till 9 p.m. H, TV till 9 p.m. H, and that will solve the purpose for us. Yeah, but there is a problem with this mnemonic. The problem is, if you see the amino acid, there are many amino acid which starts with the letter T. There are many amino acid which starts with the letter T. Many which starts with the letter T. Can you tell me some of them? Yes, tryptophan, threonine, tyrosine. You can see there are three amino acids which you know it starts from the letter T. And how many T's are there in this mnemonic? Only two. So there is one amino acid which starts from the letter T, but it is not essential. So it's a very important to remember that. Very important to remember that if you are using this mnemonic TV till 9 p.m. H, then you have to remember tyrosine is non-essential. This mnemonic is only complete if you remember this statement. What are these T actually? These T's are basically the tryptophan and threonine. Tryptophan and threonine are essential, right? Tyrosine is non-essential. Now coming to the semi-essential. I was telling you there is some controversy. The controversy is about this H. H is histidine. Histidine is essential. Let's consider like this only, because in the netball question bank, it is histidine is essential. The only semi-essential which is there in their question bank, it is arginine. If you look at in Satyanarayan it is written arginine and histidine, both are semi-essential, but in the Harper it is not written like this. So semi-essential is only one, arginine, and remaining all are non-essential. Remaining all, right? So if I write down the 22 amino acid again in the spectrum, it will be like this: TV till 9 p.m. H. These are essential. Then we have the semi-essential, arginine, and then we have the non-essential ones. Now, why I am writing like this? Because if they ask which of the following is not essential, which of the following is not essential? For example, if I give the options like this, the question is which of the following is not essential? The options are valine, leucine, lysine, and histidine. What you are going to select? Which of the following is not essential? What you are going to select? Then in that condition, you will select histidine. You will consider histidine as a semi-essential. But if I change the option, like this, again listen to the words. Which of the following is not essential? Options are valine, phenylalanine, histidine, and arginine. What you are going to select? Arginine. Right? In that case, you will consider histidine as essential. So here the questions are written. Which of the following is not essential amino acid? Instead of non-essential, just write down not essential. Which of the following is not essential amino acid? Not essential. Remember the mnemonic TV till 9 p.m. H. Tryptophan, threonine, tyrosine, methionine, TV till 9 p.m. H. In the mnemonic, these all the things are coming. Tyrosine is non-essential. Which of the following is not essential? TV till 9 p.m. H. TV till 9 p.m. H. Arginine is semi-essential. So that is going to be the answer. Arginine is going to be the answer. Look at this one. TV till 9 p.m. H. Which of the following is not essential? In this case, because you can see everything is coming above the histidine. So in this case, you will consider histidine is not essential because the remaining are purely essential. So whenever this question comes, again, you have to think logically, and then you have to consider whether the histidine will be essential or semi-essential. You have to look for the other options, and that will give you an idea. Right? If you have understood it, very good. If not, let's keep everything aside and let's keep the things very simple, because in the net board, it is like this only. Essential, TV till 9 p.m. H. There is only one semi-essential, arginine. Remaining all non-essential. Just remember like this, your MCQ will be correct. Earlier, this is all about the classification. Earlier, we were having just 20 amino acids. 21st and 22nd were recently added in the list. So we should know what is the name of the 21st amino acid. The 21st amino acid is actually selenocysteine. And 22nd amino acid is pyrolysine. These are the recently added amino acid. Cysteine, and we know that every amino acid have a codon also. Like you have your roll number in the exam, in the same way amino acid have the codons, right? That we will discuss in the chapter of nucleic acid when we will discuss translation, genetic code. So the codon for the cysteine, it is UGA, and the codon for pyrrolysine is UAG, right? You can remember like this: wherever there is a PR, there is AG, OG. If you see the husband and wife, newly coupled, newly married, because after few months the PR will washed out, right? The PR will washed out. So in the initial few months there is going to be AG, OG. So wherever there is a PR, there is going to be AG, OG, UAG, pyrrolysine. Cysteine, there is one enzyme which contains cysteine. It is thyroredoxin reductase that contains cysteine. So it's a very important chapter. It's a very important chapter that we are discussing. That is the classification of amino acid. So we have discussed total 4 classification. Let's point out the previous year MCQs. The very important MCQs. These are the ones from this chapter. Actually, I want you to write down these answers on yourself, right? Take a pause here, pause the video. Whatever you have listened, whatever you have remembered, try to fill in the blanks. And let's see then that how much we were able to retain, right? So now I am writing the answer. You just pause the video and then first you fill that and then you can again restart the video. So the alcohol containing amino acid. Do you remember the mnemonic? Yes, what was the mnemonic? Sir, Thero, serine and threonine. Very good. Maximum UV absorption, if you put in the sunlight, the maximum UV absorption. Yes, tryptophan. Highest pH. Highest pH means most basic. Highest pH means most basic. Can you tell me the basic amino acid? What was the mnemonic for basic amino acid? His last urge is very basic. The most basic is arginine. The maximum water soluble is also arginine. The maximum water insoluble, I have told you that, isoleucine. What is the codon for 22nd amino acid? What is the name of 22nd? Pyrrolysine. What is the codon? UGA or UAG? Yes, it is AG. Mosquitogenic. What is the name of the pet cat? Lucy. Yes, leucine. Most glucogenic? Alanine. Amino acid which does not have the chiral carbon. Can you tell me one amino acid which does not have the chiral carbon? We can't make the mirror image. What is the name of that? Glycine. In the beginning we have discussed about this. And there is one amino acid where the amino group is bound in a ring structure. That amino acid is called as amino acid. What is the name of that? Proline. Super important. So this was the first chapter of amino acid. It's a very important chapter, and almost every exam invariably they ask the question from this chapter, right? Try to remember the facts. These are the important previous year MCQs to be remembered. Thank you.